Hello everybody, the Network Berg here, and welcome back to another video. This is the fourth lecture of the Network Fundamentals course that I give for free on YouTube, and today we'll be discussing routers and routing. Before we jump into the actual presentation and before I showcase how routing works, I would strongly encourage you to subscribe to this YouTube channel. It does help grow the channel and it will allow me to make more material like this to upskill other individuals as well. Thank you. So let's continue. So what is routing? Have you ever wondered, whenever you go onto the internet, how does your computer know how to get to Google or how to get to another website or how it's downloading that mail? And in the background, it's all about routers, literally. It's your computer that's connecting to a router, and that router's job is just to figure out how to get the traffic to the end destination where the server is that you're trying to communicate with. And then the server that you're trying to communicate with, when it tries to send that traffic back, its routers also need to know how to get back to your computer or your IP. So that is a short principle of what routing is. What I like to do is compare or use an analogy of routing working a lot like traveling. Imagine that you were going onto a holiday destination somewhere. I've put here a map of Africa just as a good showcase as well. And when you go on that holiday, it might be quite far, it might be somewhere at the ocean, you might be living inland. A lot of the times, before we got GPS, we would look at a map and we would figure out which roads to take and how to get there the quickest. And in principle, routing works exactly the same. Your computer or your router will look at its maps or look at its roads and see which ones are quicker, faster, and how to get there reliably over the internet. So if we were to look at this map, let's say I'm down south there at Cape Town and I maybe want to end up at Cairo in Egypt at the top, at the north, then I'd have the choices to go either on this number 3 road or this number 4 road. But I can see the number 4 road is quicker just from a quick glance. So I'm probably going to take that road. And that is how routing works. Your router gets an IP packet. It will look at the packet. It will see the destination where it's trying to get to. Example is Cairo, but let's say 8.8.8.8. It will look at its own routing table and it will push that to the next hop, the next router in this line to get to that end destination. So just remember, a lot of the times when I think about routing, I think about roads and maps and stuff because it works in principle exactly the same. So what is a router? Well, a router is, in essence, it is if we're using the road analogy, it's a toll gate. So when you get to a router, from there you get the opportunity to go to different roads, but the router has quite a few functions on the network. One of the big functions, well, it's there. I'm telling you that it is a gateway. So we will get to the router and from there we will be able to decide our next hop, our next destination. Another big part the router plays in the network is it stops broadcast traffic. So a router has this job of, you remember when we were discussing switches and layer 2 and ARPs, which is a broadcast message? If you don't, I'll link that video in the description below as well. But a router also stops those ARPs, so it doesn't go to everywhere. So if your computer at your LAN range sends out a broadcast message, your router's job is to stop it at the router. It won't push it to the internet because then suddenly everybody is getting each other's ARP traffic, and that is an insane amount of traffic. Think about billions of machines suddenly saying, hello, hello, here I am, this is my IP, this is my MAC address. It would actually be overwhelming for the internet. So that's why routers also block that broadcast traffic. It stops it there. And then the last point, which I kind of delved in as well, is the router will look at its routing table whenever it gets an IP packet in order to make a decision where to forward, that's the keyword, forward the traffic to. Is it going to be a different router? Is it going to be, it's more about out of which link, out of which interface it's going to forward the traffic, because you might have, let's say, a router with 3 different interfaces with 3 different ISPs, and depending on the routing table, it will decide which interface to push that traffic out of in order to get to the end destination. But what happens is that IP packet comes into the router, it inspects the destination IP, and then the router has a rib and a fib, they call it. It's some terminology you'll get more familiar with, but just think of it as the routing table, and the router will see, okay, is this in my routing table? Yes, it is. It's telling me to go to this ISP, and then it will push the traffic out to that ISP. If nothing is matched in the routing table, generally you'll have a default route or a default route, which is a 0.0.0 route. You'll hear people talk about that a lot. Then your router will just pass it through that default route or route. If there is nothing, there's literally no route in your routing table for the packet, the router will just drop it. It will stop trying to send the traffic anywhere, and your computer will have to try and resend it until the router knows how to get there, else that traffic will just go nowhere. For more information, I strongly encourage you to go onto Wikipedia, look at routers, specifically computing, because there is some useful information there, but in the essence, that is what a router does. It sits there at our border of our networks. It allows us to get to different networks, so break out of our network, and it stops the broadcast traffic, so that's very important. I'm not going to end the video off just yet. I would like to jump into GNS3. If that's all the information you wanted, I want to thank you for watching, and maybe go onto the blog thenetworkberg.com just to read up more of these subjects. But I'm going to go now into GNS3 just to give you an idea of routing in practice from a couple of routers that will just quickly start up. So I'm going to head into GNS3. I do offer some free material how to install GNS3 on your own computer if you would like to do that. I always bring this up, but it's something good to know. It's something good to do, to be able to work on the equipment yourself. It enforces your knowledge, and it will help you get those certifications that you're looking for. Okay, so I've already created a project. I call it Routing 101. I'm just going to drag in two, or let's make it 3 different routers. They don't have to be the same make to route as well. Routers can be any make, any model. It is all basically a lot of network standardization. So routers know how to communicate with each other. You don't just need Cisco routers to be able to communicate. You can communicate with a Cisco to a Juniper, or a Juniper to a MikroTik, or however you want to. So don't feel like you're limited to one vendor whenever there's routers coming up. It is good to have the same vendors, but some routers I find are more useful in certain circumstances or situations. Okay, so I've got 3 routers. I've started them up. I just quickly want to connect a virtual computer. Let's bring up just one virtual computer. I'm not going to do a VPC. I'll do this Firefox VM thing that I've got here. Works a lot like a normal computer. And let's just bring in another one. PC2. Let's make this the end destination. That could be like a server that we're trying to connect to. So I'm quickly just going to connect these routers together so that we can have network communications. Okay, let me just bring these computers into the network as well. Okay, we've got basic layer 1 and layer 2 connectivity. We still need to do a few things like assign IP addresses between the interfaces on our routers on which they will communicate. Because remember, a lot of the times routers are kind of directly connected to each other. There might be switches and other routers between the link, but for direct layer 2 communication, when a cable goes into your router, there's going to be a device on the opposite end where those settings are also configured. So it's like one big link between maybe your house and your ISP. It eventually gets to their router as well. Just to give you some insight that a router isn't just randomly sitting there. When you get an IP address, it is also connected to your ISP network, or maybe to an enterprise or corporate network as well. Config T, let's just head into interface mode so that we can configure the interfaces here. Interface range GI. 0.0.0.2.3. I just want to unshut the interfaces on the Cisco quickly, and then I'll go specifically. Okay, so GI00 goes into router 3. Yes. Okay. So IP address. No, int GI00 IP address 10.0.0.1. We make this a /30 quickly. Let's actually do the other interfaces as well. 0/1 IP address 10.0.0.5. This is the next /30. We will learn more about subnetting later on. I just quickly want to show you how routing works. So I'm just quickly setting up these routers for you to see the bigger picture. IP, no, interface, GI0/ did I put that in 3 or 2? 3. Okay. 192.168.0.1. This will be our LAN computer. Okay, let's just quickly jump onto another router, the MikroTik. No, I don't want to look at that yet. And then remember, a lot of the software is free. If you go onto the internet, the MikroTik Cloud Core router, you can trial it for 24 hours and you can get all of the same functionality as a real router. It's really cool. Let's just go IP address, add interface, ether1. That was on the 10.0.0.2/30. IP address add interface equals ether2. This will be something new. Let's make this 10.1.0.1/30. Okay, and let's just quickly jump onto this other router, router 1. Just quickly configure it as well. And I'm not trying to confuse you. If this feels like a bit much looking at all of the configuration we're doing, you can skip a bit later on into the video where the setup's already complete so that you can just see how the routing flows. But if you look at the configuration, it might help you understand as well how the things connect with each other and how it's talking with each other. So I find that useful myself, but if you don't, just skip ahead a little bit. Config T, interface range, GI0/0.2.3, no shut. Okay, config T, int GI0/0. Okay, my 0/0 goes to that MikroTik router. So let's just give it an IP address of 10.1.0.2 with a subnet mask of /30 and an int GI0/1. Okay, so that will have the IP address of 10.0.0.6/30 because that's the next /30 range. And then the last interface, GI0/3, which is going to the computer, 172.16.0.1 on a /24 as well. Okay, so now we've got two LAN networks, which is basically the 192.168 range here on where PC1 is connected, and then there's the 172.16 range here where PC2 is connected. So if I was on PC1 and I tried to get to PC2, it actually wouldn't work yet because the traffic would get to my router here at router 2, but it wouldn't know where to go. There's nothing in the routing table. So this is what I want to show you quickly. Just before I do that, let me just configure the IP addresses on the computers as well. Okay, let's assign this 192.168.0.50. I made the router.1. Apply that. Let's jump onto the other PC. Control panel, network 172.16.0.50 as well. Gateway.1, because that's your default gateway. That is the machine or the router that your computer will use to try and break out of its own network. Let's see, ping 17.16.01. Okay, so I can get to my router there. And the other computer, can I get to my router from there? Let's just quickly see. 192.168.0.1. Yes. So I can get to my routers from both of the computers, but if I was on PC1 and I tried to get to 172.16.0.1, it's failing. Reason being, there's no routing properly set up between our routers or our devices. So this R2 doesn't know it could potentially get to this 172 range by just going to R1, or even another longer way around to R3, then from R3 to R1. So let's go into router 2 again. So I can just show you the routing table. So on the Cisco it's show IP route, but all routers have a routing table. This is what you need to understand. If you understand how routing works, you can bring that into play on any other device. The commands might be different, but the theory behind it works exactly the same. So here we can see this router, it's got its routing table here, so it knows how to get to these networks, but it doesn't have a gateway of last resort set. So that's where on Cisco you would have a default route. You would also see it as a 00 here. But all of these other networks are the interfaces that we configured between these devices. So I might not know how to get to the 172 range, but I do know how to get to the other routers. So let's quickly test that, because I gave that router to this IP address, 10.1.0.2. I should be able to ping this. Let me just quickly make sure that I didn't accidentally assign the IPs wrong. So ether 1 goes to GI0, 0. GI00. Okay, I've configured that with a different IP. Okay, I think I know what happened. I switched the IPs around a little bit. So 10.0.0.2, is that my router here? Yes. Okay, so it's just me adding too many IPs and forgetting where I put what, don't worry about it. So 10.0.0.2 is on the MikroTik, and this router knows how to get to it. So the same if I went to 10.0.0.6, which is the other Cisco, I should be able to get there as well. Yes. So I know that router 2 can get to router 3 and router 1. Let's just quickly see if the reverse is true. From router 1, can I get to 10.0.0.1, which is router 2, the other end? Okay, no. It's actually the 5 that I need to try and get to. Yes. And can I get to 10.1.0.1, which is router 3 up there? 10.1.0.1. So let's just see, can I get there? Yes. Okay, so this should mean that all the routers can actually communicate with each other. We can verify from router 3 as well quickly, but I'm fairly sure they can all talk. So 10.0.0.1. Yes, so the MikroTik can talk to the router. So router 3 can talk to router 2. And let's just do another check, 10.1.0.2. Okay, so all of the routers in this topology can talk to each other, but our LAN ranges can't talk to each other because of the routing table not having that information. It doesn't know how to get there. So let's quickly make the routers get there. I'll go more into actual configuration of routing on different equipment and setting up OSPF and BGP and all those good things later on, but I'm just going to do some static routing on these different routers to show you how we inject those routes into the network and how it's following the traffic using the routing table. So let's jump back on router 2. We already see the routing table, and we don't know how to get to our other LAN range yet. So let's quickly configure that. Config T. So on Cisco it's quite easy. IP route, and then we say what we want to route, where we want to get to. So I know we want to get to 172.16.0.0, and then we need to specify the subnet mask. it's going to be 255.255.255.0, which is the /24. And then on Cisco, we need to specify the gateway as well. So you see forwarding router address. So now we get a choice. Where do we want to push it? For interest's sake, let's push it to router 3 first. Even though we can see it's more hops to get there, let's do it that way. We'll fix it up next. So to get there, let's say go to 10.0.0.2. Okay. So if we go into this router's routing table now, we'll see this route came up here. It's being statically routed now. It's got a 1 distance, so that's like preferencing in the routing, but we now know how to get to this network. 172.16.00/24, it's subnetted with this, and we know we can get there if we go to 10.0.0.2. So let's go on to 10.0.0.2 or router 3. We can just open up the other tab again. So here, if I go out IP route print, it's the same thing. I don't know how to get to that 172 range yet, but I know it should be going to router 1 IP here. So let's just add a route for that. IP route add destination address is going to be 172.16.0.0/24, and our gateway is going to be 10.1.0.2. That's right. So now if the computer at PC1 tries to ping 172.16.0.50, it will still fail because the computer will know how to get up to this router, but you need to know how to get back as well. So this PC might be able to get to this router now, but this computer doesn't know how to get back to 192. So think about that with routing as well. You need to have return routes or routes as well. So let's just quickly implement that. It's going to be very quick. I'm just going to jump onto this router 1. Config T IP route 192.168.0.0. It's a /24 or 255.255.255.0 subnet with the gateway being 10.1.0.1. Now we need to do the same on router 3, the middle router. IP route add destination address 192.168.0.0/24. Our gateway will be 10.0.0.1. That looks right. So in essence, or in theory, these devices should know, or these routers all know how to get to 192.168.0.0 and 172.16.0.0. So let's test this out by going into PC1. I had a continuous ping running, but as you can see, I can ping it now. I'm able to get to the 172.16.0 machine and the router. And if I can get there from the 192 range, the same is true from the other side. So I can get there from here as well. 192.168.0.50. It's responding. So I know that there is network communication. These two sites can now talk to each other because of the routing that we set up. So let's quickly jump back into the routing tables. Let's go into this router 1 routing table. Route IP, show IP route. So there we see we've got, this is locally connected. The C and the L is just like it's connected locally. It's on the router, it's configured on an interface or VLAN somewhere. And the S is for static routes that we have implemented. You can see here all of the different codes there. But let's change it now. We don't want to go through router 3 anymore because we know there's a quicker way. There's one direct hop between router 2 and router 1. So let's change it. Config T IP route 172.16.0.0.255. No. We want to route the 192 from this. No, it's right. We're on router 2. 172.16.0.0.255. 255.255.255.0, and our gateway now is going to be the 10.0.0.6 IP address. Show IP route. Now we've got two different routes to choose from, and they've got the same precedence or the same metrics. So let's just quickly update as well. Let's delete the old route. No IP route 172.16.0.0.255.255.0. So we don't want to go to this router 3 anymore in order to get to the local network. So we're just going to go the one hop route now. It will still in theory work, but now we've created something they call asynchronous routing or asymmetric routing, which can be a bit of an issue sometimes. So always try and make sure your traffic goes in and out of the same interfaces, unless there's some reason you're doing that. It might be due to some load balancing or something. Okay, so now on router 1, we're going to do the same IP route, 192.168.0.0, 10.0.0.5, and then no IP route 192.168.0.0 on this subnet to the router 3 anymore. We save that, and now if we go back to our computers, you will actually see it still works, and now it is directly from router 2 to router 1, no more to router 3. So I'm going to jump back onto the routers just to show you the routing table. Go here. So on router 2, which is the left hand side, I'm actually just going to close this router 3 because we don't need it anymore. Show IP route, and then router 1, which is the right hand router, show IP route. Okay, so now we are in great shape. The computers can talk to each other. Let me just solidify what you've learned. So if I go into computer 1, which is the left hand side, and I do a ping to 172.16.0.50, what's happening is my computer is using my default gateway. So my computer is sending that ICMP traffic to router 2 saying, hey, I want to get to 172.16.0.50. Do you know how to get there? Then the routers will look at its routing table. It's like a phone directory almost, and it will say, or remember the map. It will go, how do I get there? Is it in my routing table? Let me have a look for you. Let me see, is this person in my directory? Oh yes, it is. I can see it is part of my directory. I know how to get there with some static route somebody put in. You can just go to this router, then we'll send that packet to the next hop, the next router. So it doesn't just magically get from router 2 to the computer. It will then push the traffic to router 1, and then router 1 will do the same thing. It will look at its routing table and will say, hey, I just got an IP packet, or an ICMP packet. It wants to get to the 172.16.0.50. Do I know how to get there? Let me look. Okay, I'm looking at my directory. Yes, I know how to get there. This is actually a network directly connected on one of my interfaces. I'm just going to push it out of that interface. Then that ICMP is sent out of the interface to that computer, and now we're getting a ping request to that computer, and now it needs to send that reply traffic back. So this computer will do the same process. It will send the packet to router 1. It will say, I want to get back to this 192.168.0.50 address. Do you know how to get there? Yes, I do. Go through this link. Router 2 will say, okay, you want to get back to 192.168.0.50. I know how to get there. This is how you get there. So it's constantly happening. Your routers will be looking at its routing table, trying to figure out how to get to the other networks. And that is what I wanted to teach you. I hope it has been informative, and I would strongly encourage you to get GNS3, to learn these concepts yourself with me, and also to subscribe to the YouTube channel so that I can push out more content like this. Thanks again for watching.